Hi, so welcome to the second video, which we're calling Combining Functions. This is a video where we talk about all the ways that you can take two functions and make another function from it, right? So we'll start with addition. So as you can see, I have the same kind of machine framework or machine diagram for a function because I think it is a really helpful thing to have in your head. And this is how you add two functions. So over to the left here, as always, we have a domain. And over to the right, we have a codomain. For addition, it's really important that the outputs to our functions be numbers because, well, we can add numbers. We can't add people or elephants. So how does this work? So we take an input and we plug it into both the f and the g function. We take whatever those outputs are from that function. We add them together, so this box with a plus on it is representing adding the two outputs. And then whatever we get from that addition is the final output for the sum function. And the sum function is very just simply called f plus g. So this is how you add functions, but if I take this plus here and I replace it with a times, then I've multiplied the functions instead. Or I can replace it with subtraction or division. So pretty much anything you can do with numbers, you can also do with functions. Okay, this new one is different though. This is not something you can do with numbers. This is called composition. So the way we denote composition is with this little circle between the two functions, and I just say f circle g or f composed with g. In the diagram, the way this works is we take our input and first we plug it into g, take the output from the g function and plug that into f, and then take the output from that, and that's our final output, which is going to go into our codomain. So notice to make this work, our input has to come from the domain of g, and the final output is going to end up being in the codomain of f. Okay. So do note something because it's a little counterintuitive that the first function we're plugging this into is not f like you'd think because f is the first thing that you see over here. It's actually g. So in that way it's a little bit backwards. And there's a reason for that. We'll talk about that in class. But it's so that f circle g is the same thing as f of g of x. It just makes it a little bit easier to say at the cost of this kind of weird backwardsness to the diagram. Okay, so the last way that we combine functions in this class is something called the piecewise function. So the way that a piecewise function works is you're taking the two functions, f and g, and basically you're going to decide which rule you're going to use, either the f rule or the g rule, based on what your input looks like to begin with. Okay, so over on the left, this is a common way that we would write a piecewise function. The piecewise function itself is called h. And basically what this is telling us to do, this whole thing, is it's saying if x is greater than or equal to 3, then we plug x into the f function. And if it's less than 3, we plug it into the g function. So I can draw a diagram for this. Imagine taking your input and plugging it into something I'll call a filter, which is basically just looking and saying, is x greater than or equal to 3 or is it less than 3? And if it's greater than or equal to 3, then the filter is going to send that to the left into the f function. And if it's less than 3, then it's going to send it into the g function instead. But whatever the output is, whether it's coming from the f or from the g, that's going to be our final output. So we don't do anything to the output. We don't add it or subtract it or anything like that. Okay, so we're not going to do a practice problem with piecewise functions, but we are going to see these show up in class. Great. So here are a few practice problems, 5 practice problems to look at. I'm taking the same f and the g, and I'm going to do all of these different combining functions with them. All right, so all these different ways of combining functions, adding, multiplying, composing them in either order, and dividing them. Okay, so this is a great place to pause the video if you think you can do any of these, and go ahead and give it a shot. And I'll show you the answers on the next slide. Okay, so I have here the answers to the first three of these problems. It took a little longer to write these out than I would like, so I'm not actually writing these out for you, but I am going to walk you through the steps that I used. Okay, so for part A, I'm adding the two functions together, and basically I took the f function, put it in parentheses, took the g function, put it in parentheses, and then just put a plus sign between them. And I think no matter what formulas you're using, you will never go wrong if you just put your functions in parentheses and put a plus between them. Now it turns out that for addition, the plus isn't really necessary. The plus is necessary. The parentheses aren't really necessary. I could remove those parentheses and it wouldn't change the actual formula. In fact, I could reorder the terms because I can do that under addition. And I've just done that to simplify it a little bit. So there's one thing that I'm going to say about all of these problems, which is you can write a formula and then you can simplify that formula too. And both of those things are things that I think you should be able to know how to do. However, most of the time in my class and on my tests and quizzes, you won't have to worry about simplifying unless I specifically ask you to. And in general, I don't care a whole lot about simplification. I mean, it's much more important for me that you be able to get the formula than that you be able to get it in the nicest form possible. And simplification can mean different things in different circumstances. However, I think it's a good exercise to try simplifying these. And all I've done to simplify this one, I happen to like, I like writing polynomials where the largest degree term is first. That's just why I've written the 5x squared term first. Okay, so part B is the same thing, except that instead of a plus, I've used a times. And here, the parentheses are really important because to actually simplify this, I'll want to FOIL it out. And I've done so over here, and I would encourage you to try it. These are some algebra tricks that I'd be happy to explain in more detail in class if you like. But what I've done is first I FOILed, and then I've simplified using some of the basic exponent rules, which we'll go over in more detail when we get to exponents. So if right now you're thinking, okay, I can write the formula, but I'm not quite sure how to simplify, that's an okay place to be right now. Part C, this is where things get a little more interesting. We're doing that composing trick. And I have a slogan to help you out with composition. When you're taking F composed with G, you're going to take the formula for F, and everywhere you see an X, you're going to replace that X with the entire formula for G. Okay, so I'm going to say that again. All I've done here is I've written out the formula for F, but where I had an X before, I've replaced that X with the formula for G, which is 5x squared. So that's how this became 3 times 5x squared minus 5. You can simplify that a little bit and get 15x squared minus 5. Okay, so a couple more, but I think if you followed along so far, you've gotten past the worst of it. So 2 more problems, here they are. So the second time around, or part D, I've asked you to compose these, but in the other order. So G composed with F. But it's the same slogan, just with the roles reversed. We're going to take the formula for G, 5x squared, and where we see this x, we're going to replace that with the entire formula for F. So that's how this became 5 times 3x minus 5 squared. And I've even labeled that this is f of x here for you. Okay, simplifying this one is probably the toughest simplification of the bunch, because to simplify the 3x minus 5 squared, we actually need to FOIL that out as 3x minus 5 times 3x minus 5. What I absolutely cannot do is take that square and distribute it to write 3x squared minus 5 squared. Those are just 2 different things. So I have to FOIL this out, and my strategy to it was first first take 3x minus 5 times 3x minus 5, FOIL that, and then bring the 5 outside into it. It involved some kind of tricky multiplications, some of which I'm okay if you use a calculator for. I happened to work out 15 times 5 and 25 times 5 by hand because I'm not very good at remembering things like that. Okay, so lastly, we have f divided by g. And this one's easier, I think, than the last one. I've just taken the formula for f of x and put it on top of the formula for g of x. The simplification here is that I took this fraction and I split it up into the difference of two fractions. I can do that because the difference is in the numerator, not the denominator. You cannot split up fractions when you have addition or subtraction in the denominator. Important to keep in mind. So I did that, I split it up, and then I took each fraction and I looked for common terms to cross out. Here, from the first one, I can cross out an x, which appears in both of them, and I get 3 over 5x. In the second one, I have a 5 in both of these, which I can cancel and get 1 over x squared. Okay, so I'm just going to repeat that everything on the left here for part D and E, A, B, and C, I think are good starting places. And the rest, I think, is just good practice at simplifying. And it's probably just good practice for some of those algebra rules, which we're going to need later on anyways. But I'm okay right now with you feeling like I can write down the formula, but I'm not okay simplifying it. Like I say, I think that's an okay place to be right now. We'll keep on working on the algebra in class until we're fresh with that. Okay, so I will say goodbye here, and I'll see you guys in class.